So we have to find the locus of points equidistant from the 2 points, -3, -1, and -4, 2. Equidistance means any point that I'm going to call x, y will be the same distance to -3, -1 as it is to -4, 2. So I need to use the distance formula. D equals the square root of x1 minus x2 squared plus y1 minus y2 squared. Take the square root over all of that. I'm going to plug xy with -3, -1 into the distance formula and set it equal, because it's equidistant, to the distance formula from xy to -4, 2. That looks like the square root first of xy to -3, -1 as x plus 3 squared plus y plus 1 squared. That's going to be equal to the distance from xy to the second point, which now looks like the square root of x plus 4 squared plus y minus 2 squared. So now I just have to simplify both of these equations and get it into its standard form. I have to FOIL each of these 4 squared binomials. All 4 of them have to be expanded by FOILing. I'm also going to square both sides and get rid of the square root sign. So doing both of those, we're going to get rid of the square root sign, FOIL all 4 of those squared binomials, making x squared plus 6x plus 9 plus y squared plus 2y plus 1 equal to x squared plus 8x plus 16 plus y squared minus 4y plus 4. Now we need to get all of the x's and y terms on one side of the equation, the constants, the plain numbers, on the other side. When I subtract x squared from both sides to move them to the left, notice it cancels them both out. Same thing with the y squareds. Subtract y squared from both sides. It's canceled out as well. So now the x's and y's. I'm going to subtract 8x from the right to the left. Cancels it on the right, making here -2x. Going to add 4y to the 2y, making plus 6y. Cancels here, collected like terms there. So look what I have left, all of the constants. I need to move them over to the right side. So subtract 9, it doesn't matter on which constant. Subtract 1, doesn't matter where. So cancels it on the left. Collect all of these, all 4 of those. Positive 16 plus 9 is 7. Plus 4 makes 11. Minus 1 makes 10. So it's equal to 10. Now, all we have to do is simplify our remaining equation. If you'll notice, they're all divisible by 2. They each have a factor of 2 to divide out. Plus, we need to make the x term positive, which tells me I need to divide everything by -2 to finish out this equation. My new and final equation is 1x minus 3y equals negative 5. That is the equation for all points, the locus of points, equidistant to both of these 2 points we asked for.